Awesome. Let's get started. What an amazing crowd. Thanks for joining us this morning. We have an exciting session for you, and we appreciate you being here with us. So my name is Vikram Madan. I lead product for Amazon SageMaker Ground Truth, and I'm here with Kevin Della Rosa, who's on the perception team at Snap. Really excited to have him tell you more about how the perception team is using Ground Truth. But before I jump into all this fun stuff that we have kind of set up for us, I just want to get a sense of how many folks in the audience are currently working on an ML project. If you can just raise your hands. Great. That ML project, is it using supervised learning? Cool. And if it's a supervised learning project, how many folks are doing a computer vision related? And then a natural language processing? Okay, cool. Awesome, thanks. So let's get the party started, if you will. So I'll keep this brief. Looks like we have an audience that understands the need for data labeling really well. But basically, what we've learned through our customer interactions and what we've learned from our customers is that data labeling is a very important process, part of building supervised learning, machine learning models, right? And it is extremely tedious and difficult to do, right? You need a lot of labeled data, and you need to ensure that data is highly accurately labeled. And what we learned throughout that process in launching SageMaker Ground Truth was that many of our customers, data scientists, machine learning practitioners, were spending almost 80% of their time just on building the training data set. And so from that perspective, what we wanted to do then was launch Ground Truth that would help our customers ensure that their data sets were accurately labeled, and also help them reduce the cost and increase the efficiency of data labeling. And we see Ground Truth actually reducing data labeling costs by up to 70%. Now, to kind of dive into some of the feature set, and we'll go deep on all these components throughout the presentation, at a high level, we have built-in features that improve accuracy. We have built-in features that improve efficiency of data labeling, and that's kind of primarily manifests itself through our automated data labeling capability. Now, inherently with data labeling, there's a ground truthing aspect of it. So humans in the loop are essential, right? And from that perspective, we provide kind of this data labeling platform that gives you access to Amazon Mechanical Turk, gives you access to a set of wonderful data labeling partners that provide their data labeling services to you through our AWS marketplace. We also provide an option for you to bring your own workers, right? So we host a data labeling application for you, and you can onboard your own internal teams to essentially perform the labeling for you. And then finally, we are part of the SageMaker pipeline, and we work very nicely with the different SageMaker components, right? So there's a tight integration with the SageMaker pipeline. To put this all in context, what we have is the notion of a data labeling job, right? And that data labeling job takes data, raw data, out of S3, performs the labeling on it, right? And you configure how the labeling's done. And then we output everything back to S3, which is a labeled, accurately labeled data set that you can use for training, right? And one of the core things to understand there is that we're taking your data from S3 and we're dropping everything into S3. We're not maintaining any persistent copies of your data. Everything passes through our service, which is very important when you have strict data privacy requirements, right? Now, within the context of data labeling job, you can configure auto labeling. You can configure which workforces are going to be working on your data. And our auto labeling actually learns from the workers, right? So you use them in combination. You would never use auto labeling by itself. And then also you can leverage and configure the accuracy improvement features in the context of a data labeling job. Now, in terms of what can be done in a data labeling job, let's talk about some of the use cases that we support and generally the platform itself, right? So at its core, Ground Truth is an unopinionated data labeling platform, right? So you can literally do you can set up any type of data labeling workflow using our custom workflows, right? That's what it is at its very core, right? At this stage of deep learning and this stage of machine learning, to some extent, the way you label your data is your IP, right? So we can't fathom every single use case that you're going to come up with. So at the end of the day, we have to be an unopinionated data labeling platform and give you that opportunity to build whatever data labeling workflows that you want. Now, on the flip side, we provide a number of built-in labeling tasks where we've invested significantly in the science behind improving accuracy and improving efficiency. So these are pathways that you can get started pretty quickly in a turnkey fashion and get your data labeled quickly and leverage our accuracy improvement features, our auto-labeling features, et cetera, right? And you can see kind of the two sides of the spectrum when it comes to deep learning. You see computer vision tasks like object detection, semantic segmentation, and then on the natural language side, today we support text classification and named entity recognition. And named entity recognition is generally spans of text, right? So we're going to continue to support more and more use cases in a built-in fashion, but you always have that flexibility to create your own data labeling workflow. Let's double-click in what a data labeling workflow generally looks like, and that kind of manifests exactly what a custom workflow would look like, right? So when you set up a custom workflow, kind of the central pivot is the UI that you bring to bear, right? This is the UI that the labeler is going to look at, right? We provide a number of templates that you can use off the shelf, right? These are templates that you can start as a great starting point, adjust, and they're liquid templates, which is an open source kind of standard that we use to implement those templates. But if one of those templates don't meet your needs, and we often see that, you can write your own template from the ground up. In fact, we have a large number of customers that have built Angular apps, plug them into our data labeling workflow, and are kind of running and deploy that workflow. Now, on opposite ends of the presentation of the UI to the worker, right, you can add pre- and post-processing logic. And the encapsulation there for that pre- and post-processing logic are these Lambda triggers that we have before rendering the task and after rendering the task, right? You can do very, very interesting things like, for example, pull in additional metadata or context per image, right, and add that to the task. With the pre-processing Lambda, with the post-processing Lambda, you can do kind of neat accuracy improvement type of features. Where you're consolidating answers from multiple workers. So very robust framework. You can do a lot with it. And to kind of get started and understand kind of the possibilities of link to a very, very useful blog post that we published at the bottom with that bit.ly URL. Highly recommend taking a look at it. It's a great blog post, and there's a great sample code. Now, kind of put the pin on this before we jump into a demo. Just want to quickly, again, touch on those workforce options. So Ground Truth is a layer on top of Mechanical Turk. When you kick off a data labeling job, you can configure your job to send the task to Mechanical Turk. We'll send it out to Mechanical Turk and ensure that you're getting higher accuracy results back. That's one option. If you, again, want to send it to a third party or a different workforce, you can use the vendors. We have a vibrant marketplace of vendors, really, really high-quality vendors that have gone through an AWS application security review, right? So that's very important for your data privacy, data security concerns, right? So they've gone through an AWS application security review. They're SOC 2 certified, And a lot of internal Amazon teams leverage these third-party vendors. So it's a great option to use, and it's very turnkey to set up. These vendors are listed on the AWS Marketplace, and basically you get your bill via AWS for using these vendors. And then finally, the third option, that middle option, is the private. And this is basically you bring your own workers. We are hosting a data labeling application in your AWS account. You can onboard your own workers, your own team to this account, and basically you can send the labeling task to them, right? One thing to call out there is that the identity stack is different. You don't need to give AWS IAM credentials to those workers. It's a separate identity provider, which is super, super useful. We actually use another service under the hood called Amazon Cognito. So that is ground truth in a whirlwind. Now I'm going to run through a quick demo. Before I jump into that, I just want to get a sense of how many people have actually used ground truth before. Oh, wow. That's great. So we'll do a demo from scratch. So basically, where I want to start this discussion is really kind of preface this by saying that we're going to walk through the console experience. The console experience is really designed for a general audience, and it's meant to be turnkey and easy to use, right? Throughout our kind of engagements with customers, we've learned that essentially there's a large swath of customers that we cater to. We have data program managers that are using ground truth. We have line of business users. We have, as well as data scientists and ML practitioners. So we really focused on making the console experience as easy and as accessible as possible. On the flip side, as with every AWS service, right, we have a very robust API that has a lot of configurability, right? And we have a number of examples of how to leverage the API actually in these sample Jupyter notebooks that are ready for you to use on the SageMaker notebook, hosted notebook. So you can go to SageMaker notebook, and there's basically sample Jupyter notebooks that demonstrate how to use the API. So great way to get started. But to move into the console experience here, we'll get started with the story, and the story starts in S3, right? So we have here in this S3 bucket, which is reInvent-2019-demo1, living in US East Northern Virginia, we have 14 PNGs, right? They are locked down based on whatever security policies that you have. They don't need to be publicly accessible. However, your kind of IT org wants to lock them down, they can be locked down. So let's look at one of these images and just see what it is, right? We can pull down this image. So here you see a bunch of humans, people walking in airport terminal, right? And let's say for the sake of this demo that we'll build an object detector that detects humans. And with detection, you're not only identifying whether there's humans in the image, you're also identifying where the humans are, right? So basically, this becomes a bounding box task for kind of a traditional computer vision labeling task. So that is S3. Those images are living there nicely. Let's remember the bucket for a moment, and let's go to the SageMaker console, right? So for the SageMaker console, we also go to Northern Virginia. The data needs to be, the labeling job needs to be run in the same region where the data exists. So we're in Northern Virginia. We'll go to labeling jobs. You can see as this comes up, we have a couple of labeling jobs already in progress or complete. On my dashboard, one that's complete, a couple that are in progress. We're going to start from scratch. We're going to create a new one here. I'm going to lay out the name. This is going to be, I'm just going to use the same name as the bucket here. There's no purpose for that, just want a simple to remember name. All right, so now we're going to configure the labeling job, right? So there's 3 high-level steps. First, we need to set up the input and output location. So again, remember, we're taking your data from S3. We're dumping everything back out into S3. Then we need to define the labeling task. And then finally, to complete the loop, what we're going to do is define how the data is going to be labeled, right? So who's going to label it, whether you want to configure auto labeling or not, and whether you want to use any of the accuracy improvement features. So we take in as our input data set what we call a manifest. A manifest is a simple construct here, and basically you can see it's a simple JSON lines document. What JSON lines is that each line is a JSON, and each line is line break separated. And for us, each line corresponds to one data set object. And a data set object to us is an image, right, or a blob of text. So here you can see those 14 images. We're pointing to the 14 images, and this is what you need to essentially get the job started and kicked off, right? So if you do not have a manifest or you do not want to create one from scratch, we have a nifty feature here that will create it for you, right? So basically, I'm going to point to that S3 bucket. And we are going to create it. So it's going to crawl that bucket, find those 14 images, and create the manifest. Now let's talk about why we use the manifest and why it's important, right? So when we finish the labeling job, we are going to insert all the labels into this manifest. And then you can use what we call an augmented manifest as an input into a training job. So it really enables, the manifest is a core thing that enables some of the interoperability between ground truth and the other components of SageMaker. So it's really simplified that process, right? You can also use the outputted manifest file after the labeling job is complete, when it has the labels, as an input into another labeling job. And that enables a cool feature that's called labeling jobs chaining, right, which takes the output of a completed job as the input for a subsequent job. So coming back, our manifest is created. It found the 14 images. So let's continue forward here. As I mentioned, we're dropping everything back into S3, right? So I need to have output location for my labels. I'm just going to put it in the same bucket here. And then one last thing, I need to give the service access to those objects, right, to the S3 locations. So I'm just going to specify the bucket that I want to give access to. Right. It's going to create that role for me, and we are done with the first step, right? So we've set up the input and output locations. Took about 30 seconds, right? So now let's define the labeling task, right? And as I mentioned, we support kind of these built-in use cases for images. We support some built-in use cases for text. And we also support custom use cases where you can plug in your own components. Now we'll go with images, obviously, because we're doing a bounding box task. We're doing the localization plus the identification of objects. And we're going to go to the next step. So the next step is completing the labeling tool, right? I'm going to come back to the labeling tool piece. This is actually what the workers would see just for a moment. And I'm going to go back to the worker setup option, basically to how your labeling is going to be performed. So in this case, let's intend to use Mechanical Turk. We have a couple disclaimers. There's no adult content in my 14 images, and I agree that my data will now be seen by kind of a globally distributed workforce. So it becomes public to some extent because anyone can join the Mechanical Turk workforce. Right, so I need to agree to both disclaimers. I also choose how much I want to pay each worker that performs one of my tasks. If my tasks are more complex, I should increase the pricing per task. And with that, you're ready to go. You're ready to send tasks out to Mechanical Turk. Separately, say I wanted to use a vendor. I can go to the AWS Marketplace, and this is where kind of some of the magic comes, that I can configure a vendor or choose a vendor in literally 2 clicks. So let's say I want to choose data labeling services by iMerit. I can choose iMerit. I can continue to subscribe. And then with this last click here, I'm going to agree to the end user licensing agreement, the EULA here. I see the pricing, right? So it's $6.12 per hour, and that means like that is the time that the worker spends on your task. You'll be billed $6.12 per hour. And that's billed in 17-cent increments. So every 10 seconds, you'll be billed 0.017, right, for this specific vendor, right? So kind of bringing that back home here and going back to the marketplace of vendors, you have tremendous optionality, which is super cool, right? So many of our vendors have certain specializations. So for example, iMerit also provides a US-based workforce. iMerit also provides a medical imaging kind of specialized workforce. Smart One provides Korean and Italian language skills. You'll see a variety of language skills kind of spread out in the options you have, right? We have pretty good coverage for European languages as well as Asian languages, East Asian languages. So this is a very, very powerful option for our customers. Our customers really love this feature. It simplifies a lot of the headache, and it's kind of a great marketplace of vendors. And then finally, the third option is bring your own workers. I'm going to take a little bit of an aside here to show you what this means in practice. So I'm going to go to my Labeling Workforces tab, and I am going to go to, so I see Mechanical Turk, see private and vendor. You have the AWS resource names for each of these workforces as necessary. This is what you would use in the context of the API. But I'm going to go to private and see my private workforce. So I have only one worker. It's my Amazon credentials right here, Vic Madan. I'm confirmed. I'm ready to go. I'm not a particularly good labeler, so I would definitely invite new labelers here. But for me to go access the tasks, I would go to this labeling portal sign-in URL. I believe I am already logged in, so I'll log in for demo's sake. And I can sign in here to this labeling portal, and I see the tasks that have been assigned to me. Right. So that is all good and dandy. I'm going to go back to Mechanical Turk and quickly show you some of the other quick options here. So you can enable automated data labeling with a single click. You can also use our annotation consolidation logic to generate high-fidelity labels by choosing the numbers of workers per dataset object. So by default, bounding box is sent to 5 workers. So each image is sent to 5 workers. You can increase that or decrease that. That's really a cost accuracy toggle that you have. If you want to completely turn it off, you can send it just to 1. You can send it up to 9 workers. Right? So that's really up to you. It's a little bit of an easier task, so I would say send it to 3. And then finally, you set up the labeling tool, right? So this is kind of a simplified experience for image object detection. So please draw bounding boxes around the persons in the image. Oops. And we're going to say person, and then we'll put some generic instructions here, right? And then I'm going to preview this. This is what the worker would actually see. So it's a kind of a preview. You can see that this is the UI that the worker would work on, etc. Right? These are not good instructions, obviously, and your instructions, the quality of your instructions really are directly related to the accuracy of the results that you get. We have an awesome blog post that I'll talk a little bit more about later here that you can use to kind of learn about some of the best practices that we'll talk about also later in the presentation. But your instructions are very important. So to kind of close the loop here, I'm going to go to this. I'm not going to kick off that job because the instructions are not up to the bar, but I've done this job previously. Here are the instructions that I used. Right, visual cues, some short, concise kind of points. The visual cues, the good, bad examples are particularly helpful. And then finally, you can see kind of where this data lands in S3, the output of the labeling job. You have the output manifest, and you have the intermediate worker responses as well that you will see in the annotations, right? So the worker response. So you get the outputted labels as well as you get all the raw and intermediate data as well. And then you have the visualization of the labels that came out. So this is a pretty good job, right? The bounding boxes came out generally pretty nicely. You see a lot of high confidence bounding boxes. There's a couple that are lower confidence. These are the ones that you want to spend your time on and really look at. So yeah, so that is the end of a labeling job. It's the end of our demo. I'm going to flip back here. And I'm super excited to hand it off to Kevin now. Kevin's going to talk about how Snap, the perception team at Snap, is using ground truth. Thanks, Kevin.
Yeah. Thanks. And thanks, Vikram. Thanks for having me. So yeah, my name's Kevin. I work on machine learning problems at Snap for the perception team. At Snap, we build Snapchat, the fastest way to share a moment. In this talk, I'll briefly go through how we use SageMaker, ground truth, to improve a feature called Scan. Scan is Snapchat's camera search experience, and it was originally introduced a few months ago as part of the AR bar experience, along with a set of new augmented reality capabilities. In case you missed it, I'll show you a video to show you what that's all about. So my team's goal is to make Snapchat the smartest camera in the world. Today in Snapchat, people can press and hold on the camera screen to scan and unlock relevant experiences based on what's in the viewfinder or in the environment. Under the hood, as you may imagine, this is powered by a number of different computer vision and machine learning technologies, including image classification, object detection, semantic segmentation, content-based search, ranking, and much, much more. But in general, regardless of your machine learning task, your workflow kind of looks something similar to this. Essentially, first, you want to collect data that's relevant to your task. Then you want to train a model using these examples. You want to evaluate your model to determine how well it performs. And then once you have a good enough model, you want to deploy that into production. And for us, that's either integrating it into our app or putting it into a web service. Arguably, the most important step in this flow is making sure that you have the right kind of data. And that's kind of what we're going to drill into in this section. So I would argue that computer vision quality has jumped leaps and bounds in the last decade or so. It's largely, I can attribute this largely to the availability of many open, large-scale public data sets. Things like ImageNet or Open Images, which is typically used for general image understanding for the task of classification and object detection. And then there's more, there are even large-scale data sets for very specific use cases, such as Places, which is used for place classification or scene recognition. And in the era of deep learning, the general flow that we typically see is people pre-train a model using some general large data set, such as ImageNet. Then you fine-tune this model using new data for your specific task to learn the classes that are relevant for what you're interested in. So yeah, having all this public data is great, and it can quickly help you get started. But as you deploy this into production, I find that you will see that your mileage may vary on that. So let's talk about the case of detecting hands in the scan feature in Snapchat. Today, if you scan interesting entities in Snapchat, you can unlock experiences. So if we detect that there's a hand in the viewfinder, you can unlock lenses that interact with your hand when you open and close it to do cool things. Using public data, we're able to train an initial classifier or detector for this, and we get numbers that look like they're state-of-the-art, and it indeed is able to classify my hand with high confidence. But as we started testing this out in production, we saw some different things go on as well. So we saw that in production, we're seeing the distribution of the actual images we're encountering being slightly different than what we encountered in our public data sets. So here we have a couch from our Santa Monica office that is being labeled with high confidence being hand, which is clearly not the right thing. So, and as we audited our other machine learning models, we saw similar patterns where we had mistakes that were obviously wrong. So yeah, we have a new problem where we have potentially many relevant images that we can learn from, but we don't have the corresponding labels. So what do we do? As you imagine from the title of this talk, we use SageMaker ground truth to help us on this. But why? So some of the things, here are some reasons we chose SageMaker ground truth. First, we were already using SageMaker in some of our training workflows, so it's kind of a no-brainer for us to just give it a shot. Two, we like the ability to get many images labeled on demand and relatively quickly. Next, we also like the flexibility to leverage both public and private workforces, which is relevant for different use cases at Snap. And then finally, we like the ability to kick these jobs off programmatically because it allows us to customize many different aspects. So how did we actually integrate with SageMaker ground truth? So on my team, we orchestrate many of our machine learning pipelines through Kubeflow. So it was pretty easy to use the APIs for SageMaker ground truth in this context. So I'll kind of walk through our data labeling pipeline. First, we get a set of candidate images that we might want to label. We determine that based on things that are interesting in our data warehouse. Then we do some normalization and pre-processing of these images, upload that to S3. Then we submit a ground truth job using code similar to what we have here, which is essentially the Golang API for creating a labeling job. On the worker side, they'll see a page similar to this, where you have at a glance instructions and the actual task that you have to label. You can customize just about everything on this page using the APIs. And we particularly found it useful to provide additional instructions that give more context to the user. So for example, here you can have more detailed instructions where you can kind of clear up common misconceptions or give them like detailed feedback on how to do the task. And also, we found it useful to provide examples of things people typically got wrong or things that are particularly good. So for example, in their first pass of trying to do this job, we had people passing over images that did have hands, but they were partially occluded by some object like a phone or a cup. So we gave the workers particular instructions on how to address this. We also saw a lot of images getting labeled as having a hand when it actually just had a toy or a mannequin, which isn't really relevant for a scanned use case. So we also gave them guidance on what to do for those examples. So once your workers are ready to do the work, all they have to do is select an option on the side. In this instance, there is indeed a hand in the picture. So you would click yes, and then submit to continue on to the next image. So once all the data is labeled, we do a post-processing step where we aggregate the annotations, and then we ingest it into our data warehouse. And then when we're ready to train a new model, we essentially get a list of images to train on based on like previous public datasets or things we got labeled. Transform these images into a format that our training container can understand, namely TF records. Then we kick off a training job, in this case, a SageMaker container. And then at the end, we produce a model file that we can evaluate and deploy as needed. If you want to learn more about how we use Kubeflow to orchestrate these pipelines to continuously improve our computer vision models, I have a link here to a talk a teammate of mine recently gave at KubeCon just a couple weeks ago. So yeah, what was the impact of doing this? Well, now we have the capability to gather labels for thousands of images in a matter of hours, which is pretty useful for us, like as you can get new things labeled as things diverge from what you expect. Incorporating this data did improve our models. So now like this hand classification model is actually doing the right thing for this pillow on a couch. It's no longer labeled as a hand with high confidence, it's much lower. And that's a big win for us. And along the way, we learned a lot of like simple things you can do in your jobs to get higher quality annotations. And I'll briefly go over this before handing it back to Vikram. But the keynote here is that you want to make your job as easy as possible. So to do this, you want to have very clear instructions. As I mentioned earlier, we found providing exemplar good and bad annotation examples particularly powerful. To do this, I would suggest bootstrapping this process by running a smaller set of annotations, gathering the mistakes people make, and use these as exemplar examples that are good and bad. Next, you want to opt for the smallest set of labels possible. So as you can imagine, we are interested in many, many different labels, and we don't want to throw that at the workers. So you want to narrow down the set of possible labels that they should label ahead of time. You can either do this by running some initial simple classifier detector, or you can do this by running multiple steps in your labeling pipeline. And then lastly, you want to have multiple workers working on a task. This both helps boost the overall accuracy as well as the throughput for the task. And with that, I'll kick it back to Vikram to talk more about the best practices.
Cool, thanks, Kevin. Good? So being part of Ground Truth, we are in a unique position that we get to learn from amazing customers like Kevin and the perception team at Snap. And through this process, we've kind of understood and aggregated kind of the best practices of the industry in terms of building accurate data sets as well as doing that efficiently, right? And along those lines, basically, learning from that, we've tried to enhance and build in capabilities into our platform that make it easy to execute on those best practices. And as you can see, we are basically trying to help you improve the accuracy of your data sets as easy as possible and also improve the efficiency of your processes. So I'm going to walk through each of these best practices, and since we're on the final mile, I thought I'd shake it up a little bit and introduce the world to my brand new 5-month-old puppy, who's Bubbles. So he is going to be the mascot for the next few slides. Unfortunately, he didn't make a great first impression here. He had a little bit of an accident, but we'll tell how this is relevant in a moment. So one of the things that we tell customers when we start to engage with them is that data labeling is by no means a single-shot approach, right? It's a very iterative, experimental process. And throughout that process, you learn things along the way, right? You will not have kind of a clear picture of how to get the data accurately labeled in day one, right? Your kind of clarity will come over the course of continuous experimentation. And that's just the state of the art right now, right? Along those lines, what we tried to build in Ground Truth is to allow you to easily and continuously evaluate, first of all, the accuracy of the labels that were produced, as well as adjust the labels that were produced, right? So you have these two processes, right? Label verification and label adjustment. And it's important also to separate these two processes out is the best practice, because if you just ask your labelers to perform label adjustment, there's an inherent bias that's introduced in the sense that, hey, like, I want to minimize the effort spent on the images, so I'm going to say that the label is correct, right? So it's very important to separate the label verification and label adjustment process, because you don't want to introduce that bias into the evaluation process. So how this all comes back to Bubbles, right, is that basically in this context, let's say we're building a bubbles detector, right? So I want to identify bubbles in the image, and I have to generate a training data set with kind of bubbles labeled clearly with bounding boxes. In this context, Bubbles had a little bit of an accident, and he now has a cone. But the cone should not be incorporated in the bounding box, right, for object detection, because the model is then going to learn from noise to some extent, right? So that label is incorrect, and that should be surfaced in kind of an expert review of the labels, right? And then you would send it through an adjustment process to correct the labels, right? You can learn kind of like all the features that we have on label adjustment and label verification in that link at the bottom, which is another great blog post. But I will also demonstrate kind of with the labeling job that we had run, how you can kind of kick off some of these jobs, right? So this is the labeling job that we had completed, if you remember, right? With the bounding boxes on the humans. And I want to now chain this job. So I want to take the output of this job and use it as the input for a subsequent job. So now I have a verification tab here, right, that I can use to render the labels onto the image, right? So in this context, we're coming back to setting up the verification tool. There were no humans present in this image, but there were in this one, right? So you can say label is correct, correct, incorrect, right? And you can prompt the reviewer to look at that. So that's that's the label verification. Now, what about if we want to do the label adjustment process? So let's see. There we go. So I'm going to go back to bounding boxes, and I'm going to pre-initialize the bounding boxes so they can be adjusted as necessary. Here you go. You can say, sorry, I need to specify that I want to display the existing labels. I choose the option here, and now I'm just going to preview this task, right? And it would render, actually, let me do, sorry about that. Let's pick one that has bounding boxes on it. And this is just a preview functionality that I'm showing you, but how it would look like. So the bounding boxes are drawn here. I can make adjustments to the bounding boxes as necessary and then submit the update, right? So that's the adjustment process. So very, very important kind of in the life cycle of data labeling are the evaluation and adjustment. So that's the first best practice. The second best practice here is make data labeling as easy as possible for your labelers, right? Very, very important, and there's kind of two core tenets there, right? So on one hand, you want to provide as clear instructions. You saw in Kevin's use case, you saw in the previous use case with bubbles and the cone, that helping your labelers identify the corner cases, understand what is a right label, what's a good and bad example, those visual cues, is relevant for both images as well as text, right? Giving them that sense of like what is a correct label and making sure that they're internalizing it is very important. So really, the accuracy of your training data sets goes with the instruction set you're providing. And again, the best instructions are not provided on day one. They're provided on kind of the muscle memory that you build over the course of a few iterations. It's also important to provide as efficient tooling as possible to your labelers, right? So this means streamlined UIs, easy to understand UIs, as well as automation in your UIs. And this is kind of where I want to demo another exciting feature that we just launched last week that is for our most complex labeling task, which is semantic segmentation. So let me shift back to demo mode for a moment here and go back to one of these tasks. So I'm going to go to the labeling jobs, and I am going to pull out one. I'm going to go to the worker UI that I've pre-set up. I'm going to go here. I see these tasks that are here for me to start working on. I'm going to start working on this task, right? So this is a semantic segmentation. You see Bubbles has a smile here, so he's much better now. This is a semantic segmentation task where the pixels, you're actually labeling the individual pixels of the image, right? So it's a higher precision localization task. And this task can take annotators multiple hours to complete, right? So kind of the original approach that I would take if I was doing this in a fully manual fashion is I would go with the polygon tool and start drawing a nice tight-fitting polygon around Bubbles. And this becomes extremely tedious after a certain point. And then labeler fatigue sets in, and I'm like, I don't really care anymore, right? And this is particularly painful, right? So this is not a great label. I'm going to delete this label and use the auto segment feature, which we just launched. And the auto segment feature is basically, I'm going to draw 1 point at the topmost point, 1 point at the leftmost point, the rightmost point, and the bottommost point It's going to take a moment to think and generate a tightly fitting polygon around bubbles, which is actually a tough shape to kind of do a semantic segmentation mask of. So this is a super cool feature. This is an area that we're going to continue to innovate. Adding automation to our tools is very, very important to increase the throughput as well as mitigate any labeler fatigue. So best practice number 3. This is where we talked about the annotation consolidation algorithms that we use. We take input and signal from multiple workers and output one high fidelity label, right? So in this picture of Bubbles sunning himself, you can see we sent that image to 3 workers, Vikram, Shirley, and Dan. For whatever reason, Dan is not having a good day. He did not label that correctly. But our outputted label is robust to that, right? So because we're using an annotation consolidation algorithm that takes signal from multiple workers, and we generate the high fidelity label there. Through our custom workflows, you're welcome to generate your own consolidation strategies. If you want to learn more about the ones that we specifically use, you can access that blog post. It's written by our scientists. Very, very useful blog post. All right, so best practice number 4, measuring the accuracy and throughput of your labelers, right? You want to consistently have a good understanding of what your labelers are doing well and where there might be potential issues. There's many ways to measure accuracy, many statistics for throughput that you want to calculate. Ultimately, that's your call, and we want to provide you the primitives to be able to calculate those statistics. And so along those lines, we generate the high fidelity label, but we also provide all of the raw data that each of the individual workers provided, and you have the identity information to connect back to those workers. And this is dumped into your S3 folder. We also provide output CloudWatch logs that show you which workers worked on your labeling job and how much time they spent on the task itself. Then you can kind of dive deep into the logs that we output in that blog post there for throughput. And then finally, the last best practice that we want to talk about today is label only what you need to. So this really goes around the efficiency discussion, right? So not all data is created equal. Often in case there's a lot of redundancy in data, and certain data is going to be more useful in proving the accuracy of your model. And this is really where our auto-labeling capability really shines, right? So at a high level, what's happening with our auto-labeling capability is that we're training a model under the hood that is learning based on what the humans are doing in your labeling job, right? And you actually get that model outputted to your S3 output location as well. So it's your model, it's your IP, everything's yours. We're not training any pre-trained models. But basically, you can see in this graph on the right-hand side, blue is human-labeled, orange is auto-labeled. So you see a lot of your data is human-labeled, and then the auto-labeling starts to kick in the latter phases. And so basically, you batch your data in such a way, right? So we generate a training data set, validation data set, train the model, and then we start auto-labeling where we can. Again, we have a great blog post on this with a sample Jupyter Notebook associated with it that talks in depth about auto-labeling. It's a great place to geek out. We have one of the authors actually in this room. Highly recommend you spend some time on it. But just to quickly kind of demonstrate the orchestration of what we do is that we batch your data set. So you created a labeling job, you kicked it off, and you enabled auto-labeling. And we break up your data set into batches and iterations. And so what's happening then is that in the previous example that the blog post talks about, we had 1,000 data points, right? So 1,000 images. And so in the first few iterations, we're just generating a validation data set and a training data set that we use to train your model, right? So that's why you saw all that blue. And that's 400 images that we use up front, right? And that's all going to human labelers. We're ground truthing that data. And then basically what happens is that at that point, we are able to look at the remaining 600 images. We perform an inference on them. We use a proprietary active learning algorithm to identify what does the model understand well, and what does the model understand not so well, right? So anything the model understands really, really well, we'll auto-label. What it doesn't understand well, what it understands least well, we'll send to humans and get that labeled, bring it out, bring it back, and do the whole process again, rinse and repeat until the entire labeling job is complete. So kind of just flipping back, the kind of end results here was that about 392 images were auto-labeled and 608 were human-labeled. That was the output of the job, and you see kind of auto-labeling really, really kicked in iteration 5. So that is the last best practice, and with that, I want to leave you and thank you for your time. So I think I have another slide here that was, there is an ML certification that you should take if you're interested. Very useful. But now I can come to the more important part, which is thank you for attending our session. We really appreciate your time, and we hope that this was helpful. Along those lines, please tell us what we did well. Please tell us where we can improve by filling out the survey in the mobile app. Again, thank you for your time. A few of us will be in the back, but I think we'll be shepherded out relatively soon. So feel free to stop by if you have some questions. Thank you.